Okay, here's number 14. You got three parallel lines. You know they're parallel because of the because of the little arrows right there, and you got two transversals. If you remember that, when you have this situation, you have parallel lines. These segments that are cut off right here, the 4 and the 5 and the 5 and the D, they are proportional. Now, what does that mean? That means that you can write them as a ratio, and you can set them equal to each other. That's what a proportion is. Remember how we write these. You could go this 4 to this 5. But if I do this, if I go from top to bottom, how am I going to have to compare them over here? Top to bottom, right. So if I go 4 to 5, then I would go what? 5 to D. You could do this way. You could go 4 to this 5. Well, these happen to be the same number, so it works out exactly the same thing. But let's just do that real quick. So let's go 4 to 5. Okay, let's think top to bottom. It works the same exact way if you go left to right, though. Let's go 4 to 5, top to bottom. This would be 5 to D. They're not always going to make this where this side, this segment, and this segment are equal. They just happen to in this problem. Okay, and then you just cross multiply, right? So 4D equals 25 divided by 4, and that's all you have to do. That's it. You just keep it 25 over 4. There's really no reason to change it to a decimal or a mixed number or anything. I would just keep it 25 over 4. Okay? That was pretty easy, wasn't it? I don't think this test's going to be so bad, do you? I think it'd be pretty good. Alright, let's take a look at number 2. Number 2 is a word problem. These always seem to cause little struggles for people, but let's take a look. Now remember, this is one of those problems where I seriously have no idea what these words mean. I could look them up. We're not going to right now. Maybe if I had some free time I would, but I don't. Alright, so let's just take a look. It says the ratio of, I don't even know how to pronounce these, of velites, V-E-L-I-T-E-S, okay, to principes. No idea. Anybody have any clue what those words mean? I don't know either. But who cares? All I have to know is what they start with, don't I? So the ratio of what? V to P. Right. V to P was 7 to 3. That's all I care about. Do I really need to know what those words mean? No. We've talked about this before. They do that on purpose, don't they? It says if there were 1,200 principes, or P. So watch what I do over here. I put P equals 1,200. It says how many V-lights or velites were there? V. So I put V equals. I always like to put a question mark here because I don't know what it is, right? That's going to be my variable. Now look, they couldn't have made this problem any easier. Out of all the ratio type problems, this is about as easy as they're going to give you. All right? Look what they do. They tell you the P and they ask for the V. It couldn't be easier, could it? So we put V over what? 1,200, right? Equals 7 over 3. They made this really simple. Probably because it's the first test. Okay. Later on, though, they're going to get a little more complicated than this. All right. So yeah, just do what you could cross multiply if you wanted to, but I would do this. I would just multiply by 1,200. That gets rid of the on this side. Multiply this by 1,200, and we don't need a calculator, do we? Because look, 3 goes into this 12 4 times. That's 400. 4 times 7 is 28. Brandon, you're not really using a calculator on this, are you? You really using a calculator on this? Okay. Watch how I'm doing it. I just got finished saying you don't need a calculator, and you went over there and you reached for a calculator. Come on. Play along, all right? Play my game. Here it is. Look, 3 goes into the 12 4 times, doesn't it? That's easy. Everybody can do that. You did that since you were in 3rd grade, didn't you? Right? How many times does 3 go into 12? 4 times. Got it? And then watch. 4 times 7 is what? 28. Stick a couple zeros on the end. Bang, you're done. By the time you reach for the calculator, I was done doing the problem. All right? And it's not because I'm brilliant. I'm no brilliant mathematician. Okay? Anybody could do that. Would you agree? You got to get used to doing stuff like that instead of reaching for the calculator. Sorry to pick you out on that, but it was just kind of humorous that as soon as I say don't use a calculator, you reach for the calculator. All right. So there you go. That's it. That's all there is to that. That wasn't hard, was it? All right. So here's our figure. This is the base of our figure. It's a three-dimensional object. It actually comes to a point, and how tall it is, the height of it is 6, okay, centimeters, but it's just 6 centimeters, all right? And we got to find the volume of this thing. Well, do we know the volume of a cylinder? Do you remember how to find that? It's the... I'm sorry, I said cylinder, didn't I? I didn't mean to say cylinder. it's a cone or a pyramid, okay? Now, I don't like to use the word cone because when I think of cone, I think of the base being a circle, right? They use the word cone. I would probably call it a pyramid because it comes up to a point. There's straight sides right down here on the bottom, and it all comes up to a point. And you can see the three-dimensional picture on number 19. But do you remember what the volume of a pyramid is? Isn't it 1/3? The area of the base times the height, okay? Area of the base times the height. Now, you can't have really a specific equation for this particular problem, can you? All right, because this is not just a rectangle or just a circle or just a triangle. I mean, it's an odd shape. It looks like a trapezoid, but we don't have a particular equation for that. But we do have a general equation to find the volume of a pyramid. It's 1/3 the area of the base times the height. We good with that so far? All right, so let's figure out some stuff. Really, the only thing I got to find is the area of this base, isn't it? Okay, and how do I find the area? Well, it's broken up into like 3 different sections, isn't it? So let's do this section first. This is a rectangle, isn't it? So what's this? You follow me between these 2 dotted lines? So that's a rectangle. So what is the area of a rectangle? Length times width, or what? 4 times 3. There's 4 and there's 3. Everybody with me? So the area of that middle part right there is just 12. What about the area of this? Now, you were saying earlier that you wanted to find this side right here. But do you really need to find that side? No, you don't, because this is a triangle, isn't it? It's a right triangle. So what's the area of a triangle? It's 1/2 the base times the height, isn't it? Okay, so it's 1/2 the base times the height. Well, what's the base of this? Of just this triangle right here. What's the base of that triangle right there? It's 2. All right, what's the height of this triangle? It's 3. Okay, that's 6. 1/2 of 6 is what? 3. So the area of this triangle is 3. Come over here. What about this triangle right here? Same exact thing, isn't it? Because it's got a base of 2 and a height of 3. So it's exactly the same thing. Do I have to go through all that again? No. So look what I got. I got 3, I got 12, and I got 3. That's 6, and 12 is what? 18. So the area of the base is 18. Look, they've rigged this big time for you to make the numbers come out nice and easy. No calculator needed. Have I needed a calculator once on this problem? Absolutely not. So watch. 1/3 of 18 is the same thing as what? 18 divided by 3, right? You follow me? Okay, times the height also, right? 6. If I wanted to do this, I could. Either way you do it. 18 divided by 3 is what? 6 times 6 is 36. That's the volume. No calculator needed. They're not interested in the little intricate numbers, okay? They're interested in how to set the thing up and how to solve for it. They're not putting real crazy numbers in here right now. Maybe eventually they will, but right now they're not. They're making it really easy for you so you don't waste all your time doing this little minute arithmetic, right? They just want to know that you know to find the volume, you go 1/3 the area of the base times the height. That's what's important about this problem, right? And then you find the area of these things, know how to find the area of a rectangle, the area of a triangle, and then add them all up, multiply by the height, take 1/3 of it, boom, you're done. Make sense? Anything else? Have we covered everything now? Yep. Except the constructions, right? So you're going to have to go. I mean, these constructions are exactly the constructions that we did in class, right? Now, we didn't put that on YouTube because really couldn't. But we did go over it, right? Did it on the overhead, remember that? And I told you to take notes on it. So go look at them and figure out how to do the constructions. Make the correct arcs and all that. That's what I want to see. Now, watch. If they do this, if they give you an angle and they say bisect the angle, all right, I am not going to accept you just doing this, just eyeballing it and say, oh, there it is, I bisected it. That's not what we're going to do. You got to put the arcs in there. Remember how to bisect an angle? I'm going to do it without, I don't have a compass on me right now, but watch. What do? Strike an arc, right? And then I take that point of the compass, I put it right here, and then I stretch it out this far, and then I strike an arc this way. And then guess what I do? I put the point of the compass right here, and I strike an arc the other way. See that point of intersection of those 2 arcs? I just take my line, and I go from the vertex. Oops. Let's get on the vertex. And then I go through that point. That's what I'm looking for. Okay, I'm looking for this big arc, and I'm looking for these little 2 arcs. I'm looking for that point of intersection. I'm looking that you connect them. Make sense? All right. So that's how I'm going to grade the constructions. I mean, to tell you the truth, I'm not going to be really, really strict on the constructions, but I do want to see a few things. I want to see the arc, and don't just draw an arc like I did. Use the compass, all right, to make a nice, pretty arc right here. Can stretch from here. Oops, stretch from here to here. Make the two arcs. Find the point of intersection. Boom, and you got your bisector. We okay? All right. All right, that's it. That's pretty good timing, and we're done. So test tomorrow, 20 questions, just like this. Okay, it's in the same order, same basic pictures. They might change slightly. The numbers will change slightly. The word problems will be basically the same type of word problem. They might not use the same words, like the ratio of the volites to the principes or whatever that thing is called. I have no idea. But it's going to be the same basic kind of problem. All right, good luck to you. Study. Go through your YouTube videos. Hang on to that. You can use that to study from, okay? I'll collect that tomorrow. All right, so that the thing we just went over right now, I'll collect it tomorrow, right before the test. And there we go. Look, I would time myself. What I would do tonight if I were you, I would retake this thing. Just sit down and set your timer to 40 minutes or whatever. We have roughly 40, 45 minutes, something like that in here. By the time we get started, it'll probably end up about 40 minutes. Set a timer to 40 minutes, and then just sit there and work on it. That's 2 minutes per problem. All right. Now, not every problem is going to take 2 minutes. Some will take a lot less. Some may take a little longer, but they all balance out. All right. So make sure that you practice it, and you can finish within 40 minutes, because that's it. All right. We're done after 40 minutes.